Assalamu alaikum everyone. In today's presentation, our group is going to present our project on student performance prediction using the UCI student performance dataset. So my name is Abdullah Al Noman. My ID is 232350003. So first, let's take a look at our dataset. What we worked in. Our dataset contains information about students from the two different subjects, mathematics and Portuguese. We have two files, student math CSV for the math class and student port CSV for the Portuguese class. Interestingly, 382 students appear in both files, so we can connect their records and get a more complete view of their performance. Each file contains around 33 columns, including information about students' age, family, student habits, previous failures, alcohol consumption, absence, and their grades G1, G2, and G3. Our main target is G3, which is student's final grade on a scale from 0 to 20. We use the other information to help us understand and predict student performance. Before doing any analysis, we need to make sure that data is reliable. The good news is that original dataset has no missing values, and we verified this ourselves. However, no missing values doesn't mean that data is completely ready to use. We still found things that need to be cleaned, such as inconsistent column names, data types, and category values. For example, a column name like MEDU can be standardized to smaller case MEDU so that our dataset is easier to work with it. So to prepare the dataset, we applied six cleaning steps. First, we standardized the column names. Second, we checked every column for missing values and confirmed that there are none. Third, we checked for the removed duplicates. Fourth, we cleaned text and category values to make them consistent. Fifth, we corrected the data types, especially for categorical values. And finally, we checked for impossible values such as invalid ages or grades outside the range of 0 to 20. After these steps, we had to clean and reliable dataset, ready it for analysis and prediction. Now I will hand over to my other teammate who will explain the next phase of our project. Thank you.
Assalamu alaikum everyone. My name is Adnan Iqbal and my ID is 232350024. Today we will explain models only understand numbers, not text. So a column like a school has just says GPA or MS may had to convert it. We used one hot inputting splitting into two 0 and 1 columns is GPA and MS. So the model can actually read it. We also flagged columns where almost every student had the same value since those don't help predict anything. Uh, Before making charts, we explored using plain numbers, taking row and column counts, data types, and building frequency tables like how many students, mothers work in each job category. We also process tab things like school versus pass fail and build a correlation matrix to see which number moves together. Then we explore visually. G3's histogram showed most of the students in the middle part a separated group scoring 0. Confirmed as outliers by the box plot, our biggest finding G1 versus G3 had 0.80 correlation, meaning if a student does well early, they usually finish well too. Our heat map showed this at a glance. Darker boxes meaning stronger relationship. Then lastly, we compared groups, mothers, jobs, internet access by urban and rural areas. These scores across two schools. So that's all for my presentation. Now my teammates will cover the deeper statistic analysis.
Assalamu alaikum. My name is Rashidul Islam and my student ID is 232350066. Uh, First, let's look at the descriptive statistics. We analyzed 395 students. The mean of final grade is 10.42, while the median is 11, showing that the typical score is around 10 to 11. The standard deviation is 4.58. It means the grade vary moderately around the average. The grade range from 0 to 20, and the skewness is minus 0.73, tells us the distribution is slightly left skewed because of some low scores. Uh, Next, we checked for outliers using four methods: the IQR rule, range check, G-score, and modified G-score. None of them these methods detect any statistical outlier. However, we found that 38 students, or 9.6% of total student scored zero. Since this is zeros most likely represent a student who misses the final exam rather than data entry errors. We kept them in dataset so that we can find a real pattern. Uh, then we performed a normality check using the Sharpio-Wilk test. The p-value was less than 0.001. So we concluded that the grades are not normally distributed. The histogram and QQ plot support this result, mainly because of the cluster of zero scores. Uh, Finally, we carried out a hypothesis test. The independent t-test found a small but significant difference between male and female students. The paired t-test showed the final grades were slightly lower than the first period grades. However, both the ANOVA and chi-square test found no significant relationship. Now, I will ask my next team member to explain more about our dataset.
Assalamu alaikum. I am Ashraful Alam. My ID 232 Now I will discuss our sampling methods, correlation, scaling, and PCA analysis. First, we practiced 5 sampling techniques: simple random, systematic, stratified, cluster, and bootstrap sampling. Simple random gives every student an equal chance of selection, and systematic selects every kth student. Stratified keeps the pass-fail ratios balanced, while cluster selects whole groups. Finally, bootstrap uses sampling with replacement to measure uncertainty. Let's see how variables relate to each other. We studied the relationship between variable using Pearson, Spearman, and Kendall correlation. For G1 and G3, the Pearson correlation is 0.801, which indicates a strong positive relationship. We also found that G1, G2, and G3 are highly correlated with each other. Putting variables on the same scale. Here we compare different scaling methods, including Z-score, min-max, robust scaling, and log transformation. For absences, the original skewness was 3.66. After applying log transformation, it became 0.07. So the distribution became much more balanced. Finally, we analyzed variables together. We found that more past failures are associated with lower final grades. We also used PCA, or principal component analysis, to reduce many numeric variables into two components. The PCA plot shows some separation between the pass and fail groups. So that's all from my part. Now my friend Radwan Ahmed will explain the modeling and final result. Thank you.
Assalamu alaikum. I am Radwan Ahmad. My ID is 232 I will be presenting the final part of our project, building and judging the models. In this part, I will explain splitting the data. We split data 70, 50, 50 into train, validation, and test. We removed G1 and G2 since predicting G3 from them would be cheating. RMC from 1.87 to 3.35 after removing. In this part, I'll explain model we tried. We tried 11 regression model like random forest, KNN, XGBoost, SVR, RAID, etc. For exact grade, and 13 classification model like LDA, QTA, SVM, KNN, begging, etc. For pass or fail. In this part, I will explain how we judge the model. For regression, we use MAE, RMSE, R squared, and for classification, accuracy, precision, recall, F1, AUC. Recall method most cheating at least student. Best regression, random forest, best classification, bad trees. In this part, I will explain overfitting and tuning. We compared train validation and test score, GVM overfit. RMSE jumped from 1.4 to 4.1. We tuned random forest, KNN, and SVM for better result. Best regression, random forest, RMSE 3.74, and we find best classifier batteries accuracy 60%. Past failures and absence predict a grade best. Can help flag at-risk student early. And our limitation is regression specific self-reported data. Thank you, sir, for your attention.